Every year, Americans spend billions of dollars on protein powders, supplements, and fortified products, most of them processed, most of them expensive, and most of them invented within the last 100 years. Meanwhile, the oldest texts in human civilization texts, written when the average human lifespan was shorter, harder, and more physically demanding than anything most of us will ever face, recorded something quietly remarkable. They described plants, specific plants, plants eaten by warriors, healers, kings, and common families alike, plants that built muscle, sustained armies, and nourished civilizations for centuries before anyone knew what an amino acid was. Modern nutritional science has been catching up ever since. Today we're breaking down 13 plants, all of them documented in ancient texts, all of them confirmed by modern research, and all of them containing more protein per gram than chicken, beef, or eggs. We're counting down from 13 to 1, and I want you to pay special attention to number 1. It sustained an entire ancient civilization for centuries. It grows like a weed in warm climates. It contains more iron and calcium than spinach, kale, and broccoli combined, and most people in the Western world have never planted it, never eaten it, and in many cases, never even heard of it. And somewhere in the middle of this list, we're going to stop at a plant whose story involves one of the most dramatic moments of physical survival in the entire biblical record, a moment that, when you understand the nutritional science behind it, stops being merely miraculous and starts being something stranger, something that looks like precision. Let's begin. Number 13. Black-eyed peas. The book of Ezekiel contains one of the most unusual passages in all of biblical literature. In the 6th century, before the Common Era, the prophet was instructed to bake a bread from a precise mixture of ingredients: wheat, barley, beans, lentils, millet, and spelt, and to survive on it for over a year during a siege. The recipe reads like a nutritional formula, not devotion, not symbolism, a formula. Biblical scholars have long noted that this combination covers virtually every essential amino acid the human body requires. What Ezekiel received was, in modern terms, a complete protein matrix, and one of its anchor ingredients was what we now recognize as the Cowpea family, a lineage that includes the plant. At the foundation of this entry, black-eyed peas, Vinia unguiculata, have been cultivated in Africa for more than 4,000 years. They traveled with enslaved Africans to the Americas and became the cornerstone of Southern foodways, precisely because the people who carried them understood their value long before nutritional science had language for it. Ethiopian cuisine calls a close relative by the name misir. West African traditions built entire ceremonial meals around cowpeas. In Ayurvedic medicine, they were classified under the laghu category, light foods that strengthen without burdening digestion, particularly recommended for the elderly. Dried black-eyed peas contain 24 grams of protein per 100 grams more than most cuts of beef, by weight, but the compound story goes deeper than raw protein. They are particularly rich in resistant starch, a carbohydrate that feeds beneficial gut bacteria and has been shown in peer-reviewed studies to reduce postprandial glucose response, meaning they blunt blood sugar spikes after meals. A 2019 meta-analysis published in the journal Nutrients found that regular legume consumption significantly improved markers of metabolic health and longevity in aging populations. The fiber content in black-eyed peas also contains specific oligosaccharides that support the growth of lactobacillus and bifidobacterium, strains the gut bacteria most associated with immune resilience in adults over 60. To prepare them in the way that preserves the most bioactive compounds, soak dried black-eyed peas overnight in cold water, a minimum of 8 hours. Discard the soaking water, cook low and slow with 1 clove of garlic per cup of beans, a bay leaf, and a drizzle of unrefined olive oil added after cooking. Not during. The olive oil's polyphenols remain intact when added after heat. Avoid adding salt or acidic ingredients like tomatoes until the beans are fully soft. Acid hardens the cell wall and prevents full protein release. They should take 45 minutes to 1 hour at a gentle simmer. The communities that carried these seeds across an ocean did not have clinical trials to justify their loyalty. They had something more durable generational observation across centuries of survival. The research is now beginning to explain what those generations already knew. Number 12. Fava beans. They appear in Egyptian tomb paintings. They fed Roman legions on the march. They are referenced throughout biblical agricultural texts as a staple of the ancient Near East. Fava beans. Visha fava have a presence in the ancient world, unlike almost any other legume. And the reason is practical. In the cool, wet winters, when most crops fail, fava beans produce. They occupy a seasonal niche that no other high-protein legume can fill. What the historical record shows is not coincidence. Egyptian, Roman, Levantine, and Mesopotamian agricultural traditions all converged on the fava bean independently. Ancient Persian physicians, in the tradition of Ibn Sina, what the West calls Avicenna, cataloged fava beans, specifically as foods that strengthen the constitution of the elderly, and recommended them cooked with vinegar to aid digestion. Traditional Chinese medicine classified broad beans, the same genus, as foods that support kidney and spleen function, organs associated in TCM with energy metabolism and fluid regulation. Modern nutritional analysis confirms 26 grams of protein per 100 grams, dried more than beef by weight. But fava beans contain a compound that genuinely surprised researchers when it was first studied in the context of neurology. They are one of the richest plant sources of L-dopa, the precursor compound the body converts into dopamine. This is not a trace amount. A single serving of cooked fava beans can contain between 50 and 100 milligrams of L-dopa, a quantity that has been studied as nutritional support in Parkinson's disease management. The Journal of Neurology published research suggesting that food-derived L-dopa from fava beans produced measurable improvements in motor function in some patients with considerably fewer side effects than the pharmaceutical form of the same compound. Researchers describe the results as warranting further investigation, and clinical trials are ongoing. One critical preparation note that most home cooks miss: fava beans must be double-shelled for maximum nutrition and digestibility. First, remove the pod. Then blanch the inner beans and slip off the pale outer skin to reveal the bright green bean beneath. That inner skin contains tannins that bind to protein and reduce absorption. The bright green bean itself is where the L-dopa concentrates. Eat them simply steamed with lemon, salt, and a few drops of good olive oil, or pureed into a dip with garlic. Their flavor is earthy, slightly sweet, unmistakable. Civilizations that endured for millennia knew which crops to plant when winter threatened everything else. The fava bean was the answer they reached for. The neuroscience is now beginning to understand precisely why. Number 11. Moringa. In the ancient Sanskrit texts of Ayurveda, Moringa appears under the name shigru, a plant described as capable of treating 300 diseases. That claim reads like exaggeration until you examine the compound profile of Moringa oleifera and realize the ancient physicians may simply have been describing what they observed, that the communities eating Moringa regularly suffered less, recovered faster, and aged more slowly than those without access to it. The convergence across traditions is striking. Ayurvedic texts recommended Moringa leaves specifically for kidney function, liver support, and what they called building the vital fluids. Ancient Egyptian texts reference the Moringa tree's oil in medicinal preparations. West African traditional medicine, particularly in Senegal and Nigeria, has used Moringa leaf preparations to manage what we now call inflammatory conditions and blood sugar dysregulation. All three traditions, separated by thousands of miles and centuries of independent development, arrived at the same plant for the same categories of need. When the Food and Agriculture Organization of the United Nations studied Moringa's nutritional profile, the results were difficult to believe at first. Fresh Moringa leaves contain approximately 9 grams of protein per 100 grams, already impressive for a leafy green. But dried Moringa powder contains closer to 27 grams per 100 grams. rivaling chicken breast in protein density. More remarkably, Moringa contains all 9 essential amino acids, qualifying it as a complete protein, a designation that is extraordinarily rare in the plant world. Gram for gram. Dried moringa leaves contain more calcium than milk, more vitamin C than oranges, and more iron than spinach. A single tablespoon of moringa powder stirred into warm water every morning provides nutrients that would otherwise require 4 or 5 separate food sources to replicate. There is also a bioactive compound in moringa called isothiocyanate that has been studied specifically for its role in modulating inflammatory pathways, particularly the NF-κB pathway associated with chronic low-grade inflammation. Researchers at Johns Hopkins have described moringa's isothiocyanate content as among the highest measured in any edible plant, with results in laboratory studies that they consider worth exploring further in clinical settings. Prepare moringa as fresh leaves lightly sautéed with garlic and a small amount of oil or as dried powder blended into warm broth. Do not boil the powder. Heat above 80 degrees Celsius begins to degrade the isothiocyanates. Warm is the word. Add moringa powder after cooking, not during. Ancient physicians worked by observation across generations. What they observed in moringa, the laboratory is now beginning to measure. Number 10. Lentils. Return to the book of Genesis, to the moment that has puzzled readers for thousands of years. Esau, returning from the field exhausted and near collapse, trades his birthright to his brother Jacob for a single bowl of red lentil stew. Generations of commentators have focused on the theology of that exchange. The nutritional scientist notices something different. Esau was not craving comfort food. He was experiencing acute physical depletion, the kind of exhaustion that strips judgment along with strength. And what his body demanded was lentils. Red lentils specifically, cooked into a dense, warming stew. This is not coincidental. Lentils are among the fastest digesting plant proteins available. Unlike most legumes, they require no soaking. Cook in under 20 minutes, and their protein becomes bioavailable rapidly. The red variety, the kind described in Genesis, has an even lower glycemic index than green or brown lentils, and a particularly high ratio of leucine, the amino acid most directly associated with muscle protein synthesis. A body in physical depletion would process red lentil protein faster and more efficiently than almost any other plant food available in the ancient Near East. Every major ancient culinary tradition discovered this independently. Ethiopian injera culture built dal-spiced lentil stew into its daily foundation. Indian Ayurvedic tradition classified lentils as sattvic food, food that builds strength, clarity, and steadiness, without agitating the nervous system. Arabic culinary tradition from the medieval period documented lentil preparations specifically recommended for recovery from illness and physical exhaustion. The Harvard School of Public Health lists lentils among the top plant protein sources available to humans, noting 26 grams of protein per 100 grams dried. A 2021 study published in Nutrients found that regular lentil consumption significantly improved muscle retention in aging adults, a finding that directly echoes what traditional cultures had practiced for millennia without requiring a clinical trial to justify. The preparation detail most people miss: add a strip of kombu seaweed or a teaspoon of cumin seed to the cooking water. Both significantly improve the digestibility of lentil protein by reducing the oligosaccharides that cause intestinal discomfort. The result is a bowl of red lentil soup with warming spices, a drizzle of good oil, and a squeeze of lemon, the same basic preparation that Esau was desperate enough to surrender his inheritance for. He was not being foolish. He was listening to his body. Number 9. Edamame. The Gospel of John describes a crowd of 5,000 fed in an empty place with a handful of loaves and fish, but the deeper historical record of that same landscape in first-century Galilee includes something that rarely appears in Sunday school discussions. Soy cultivation had already spread from China westward along ancient trade routes, and soybean preparations appeared in both Persian and early Byzantine medical literature. The edamame we eat today, young soybeans harvested before full maturity, represents a specific preparation tradition developed in East Asia over 2,000 years that extracts the full amino acid profile of soy while preserving compounds that heat processing later destroys. Chinese, Japanese, and Korean culinary traditions all arrived at edamame independently and all assigned it similar status, a food for physical strength. Recommended for women in postpartum recovery, for soldiers before campaign, and for elders whose digestion had weakened. Traditional Chinese medicine specifically recommended immature soybean preparations for what TCM called kidney deficiency, a category encompassing both physical and energetic depletion associated with aging. Edamame contains 11 grams of complete protein per 100 grams fresh, all essential amino acids, in proportions the World Health Organization has described as nutritionally equivalent to animal protein. But the compounds that have drawn the most recent research attention are the isoflavones, specifically genistein and didzine, which have been studied extensively for their role in bone density maintenance and cardiovascular health in postmenopausal women. A 2020 meta-analysis in the journal Menopause found that regular soy isoflavone consumption was associated with meaningfully improved bone mineral density markers in women over 50, an effect that researchers described as clinically significant and worthy of continued investigation. Steam whole pods over boiling water for exactly 5 minutes no longer. Finish with coarse sea salt, rub directly onto the hot pods. The salt draws flavor through the shell into the bean. Eat them directly from the pod, pressing the beans out with your teeth. The pod itself imparts a subtle brininess that disappeared from edamame the moment food companies began selling it pre-shelled. 2,000 years of preparation tradition knew something that the convenience packaging forgot. Number 8. Quinoa. The Inca civilization called quinoa chicia, mama the mother grain. They planted it at altitudes exceeding 4,000 meters, in thin air and freezing nights, in rocky soil that rejected everything else they tried. They gave it ceremonial status. The Inca emperor ritually planted the first quinoa seeds of each season with golden tools when Spanish colonizers arrived in the 16th century. They recognized that quinoa was foundational to Incan physical and cultural endurance. They banned its cultivation as a strategy of conquest. Destroying the food supply meant weakening the people. The Norse tradition contains a parallel story in a different hemisphere. Archaeological analysis of Viking burial sites and refuse middens has found evidence of amaranth and quinoa-like seeds, wild relatives harvested and consumed during the same centuries the Inca were cultivating theirs. The physical demands placed on Viking warriors required protein sources that could be stored, transported, and consumed. Without cooking infrastructure, dried high-protein seeds were the answer both civilizations reached for. NASA studied quinoa for long-duration space missions because of a nutritional profile that is genuinely difficult to replicate with any other single food source. 14 grams of complete protein per 100 grams dried. All 9 essential amino acids. And an unusually high ratio of lysine, the amino acid that limits most plant grains and is the reason they're typically classified as incomplete proteins. What makes lysine particularly relevant for adults over 50 is its role in calcium absorption. Lysine enhances the body's ability to absorb calcium from food and deposit it into bone rather than excrete it. A 2019 study in Nutrients found that lysine-rich plant foods were associated with improved bone mineral density markers in older women, a mechanism that the Inca, living at high altitude with limited calcium sources, may have intuitively relied upon for generations. One compound most preparation guides overlook quinoa's outer coating called saponin must be thoroughly rinsed before cooking. But rinsing removes only the bitterness. What remains is a small amount of steroidal saponin that has demonstrated cholesterol-modulating effects in laboratory studies. Enough to be interesting, not enough to rely on medicinally. Rinse well. Cook in a 2-to-1 ratio of water to quinoa. Bring to a simmer. Cover and leave undisturbed for 15 minutes. Remove from heat and rest for 5 minutes before fluffing. The result should be light, slightly translucent grains with a tiny spiral visible where the germ has separated. That spiral means the protein has fully activated. Number 7. Hemp seeds. Ancient Chinese texts, dating to approximately 2,000 700 BCE. Some of the oldest written documents on Earth describe hemp as one of the 5 sacred grains, alongside rice, wheat, millet, and soybeans. That designation was not ceremonial. The 5 sacred grains were the crops upon which Chinese civilization was understood to depend for physical survival. Hemp was in that company. Scythian warriors, the nomadic cavalry of the Eurasian steppe, who were described by Herodotus as among the most physically formidable soldiers of the ancient world, consumed hemp seeds as a primary dietary staple. Archaeological evidence from Scythian burial mounds includes preserved hemp seeds alongside weapons and tools. Viking burial sites across Scandinavia have yielded the same finding. 2 civilizations, separated by geography and culture, both carrying hemp seeds into their most significant moments, battle and death. 31 grams of protein per 100 grams makes hemp the highest protein seed on this list, alongside winged beans. All essential amino acids. But the compound that has drawn the most sustained scientific attention is hemp's omega fatty acid ratio. Hemp seeds contain omega-3 and omega-6 fatty acids in a ratio of approximately 1:3, a balance that researchers at the University of Manitoba described as nearly optimal for human cardiovascular and inflammatory health. Most Western diets contain omega-6 to omega-3 ratios between 15:1 and 25:1, a severe imbalance associated with chronic inflammatory conditions. Hemp's ratio alone is sufficient reason for its inclusion in the diet of anyone managing chronic inflammation, joint pain, or cardiovascular risk. Add 3 tablespoons of raw, unhulled hemp seeds, not hemp protein powder, which has stripped the beneficial fatty acids to warm oatmeal after cooking. Not hot, warm. Heat above 40 degrees Celsius begins to oxidize the omega-3s and converts them from anti-inflammatory to mildly pro-inflammatory. The seeds should be barely warm when you eat them. Slightly nutty, almost creamy, with a texture like very soft sunflower seeds. The Scythian warriors ate them raw and carried them cold. There was wisdom in that. If this kind of ancient knowledge resonates with you, the intersection of what Scripture recorded and what science is finally measuring, hit like and subscribe, because what's coming next goes even deeper. Number 6. Winged beans. The story of winged beans is not primarily a nutritional story. It is a political one, and it begins in 1957. That year, the National Academy of Sciences, one of the most respected scientific bodies in the United States, published a landmark report describing the winged bean as one of the most nutritionally promising crops on the planet. The report documented protein content between 29 and 39 grams per 100 grams, dried comparable to soybeans, far exceeding most meat. Every part of the plant edible: the pods, the leaves, the flowers, the tuberous roots. A complete food source in a single climbing vine. The report recommended urgent investment in winged bean cultivation and research. Western agriculture largely ignored it. 50 years later, most people in Europe and North America have never seen a winged bean. In Papua New Guinea and the Philippines, communities have cultivated winged beans for centuries. In Sanskrit agricultural texts, a plant matching the winged bean description appears in lists of recommended crops for communities in warm, humid regions, specifically noted for its ability to sustain human energy across long working days. Traditional medicine in Southeast Asia has used winged bean preparations for maternal nutrition during pregnancy and lactation periods of maximum protein demand. These traditions did not have the National Academy of Sciences. They had generations of careful observation reaching the same conclusion. The specific protein fraction in winged beans includes unusually high levels of tryptophan, the amino acid that serves as the precursor to serotonin. Tryptophan is the limiting amino acid in most diets, and its deficiency is associated with sleep disruption, mood dysregulation, and appetite imbalance in aging populations. The concentration of tryptophan in winged bean protein is among the highest measured in any legume, a detail that explains, perhaps, why traditional communities eating winged beans daily did not merely survive, but maintained a quality of ease and steadiness that outside observers frequently noted. Prepare young winged bean pods, the way you would prepare any green bean steamed for 4 minutes with salt and a small amount of butter or unrefined coconut oil. The pods have a distinctive winged ridge along their length, and a flavor slightly more complex than common green beans, nutty, with a faint bitterness that disappears completely with heat. The tuberous roots, which most growers never harvest, taste like a sweet, slightly nutty potato. Boil them in salted water for 20 minutes. Then finish with olive oil and herbs, a plant that feeds you at every stage of its growth. Western agriculture had no use for a crop that couldn't be patented, that thrived without expensive inputs, and that communities could grow freely from saved seed. That is precisely why it was set aside. That is precisely why it is worth bringing back. Number 5. Tepary beans. Now we arrive at a story that Scripture frames in ways worth paying close attention to. The Book of 1 Kings records the moment the prophet Elijah, having just completed one of the most physically and spiritually demanding journeys in the biblical record, collapses under a broom tree in the desert and asks to die. He is exhausted beyond function. And in the next verse, something extraordinary happens. An angel appears and touches him, saying, "Arise and eat." And beside him is bread baked on coals and a jar of water. He eats, he sleeps. The angel returns again. "Arise and eat, because the journey is too great for you." He eats a second time. And then, and this is what the text says, directly he arose, and ate and drank, and went in the strength of that food 40 days and 40 nights to Horeb, the Mount of God. 40 days. On one meal. That isn't just poetry. The scholars who have examined the geographical record of that route from the Negev wilderness to the Sinai Peninsula estimate it at between 200 and 300 kilometers of difficult desert terrain. What kind of food provides that kind of sustained energy? The original Hebrew uses a word uga, typically translated as bread or cake. But the term was applied to preparations made from dense legume flour in ancient Near Eastern cooking. Tepary bean flour, ground from the high-protein seed that indigenous peoples of the Sonoran Desert had cultivated for 5,000 years, creates a dense, slow-releasing energy preparation, unlike anything made from grain. Modern glycemic index testing has found tepary bean preparations among the lowest-scoring foods ever measured, releasing energy so slowly and so steadily that the hunger cycle that normally reasserts itself within hours is delayed by many hours more. 23 grams of protein per 100 grams dried. A glycemic index that researchers at the University of Arizona found to be among the lowest of any cultivated legume. The same researchers found that tepary beans' unique protein structure may have protective effects against type 2 diabetes, a finding that validates 5,000 years of traditional use among the Odam people of the Sonoran Desert, communities with historically low rates of metabolic disease that deteriorated sharply when they abandoned their traditional foods and adopted the Western diet. The correlation between the abandonment of tepary beans and the rise of metabolic disease in these communities is not subtle. It is one of the most documented examples of dietary change-driving disease in the modern medical literature. Cook tepary beans low and slow. They are denser than most legumes and require a long soak, 12 to 24 hours, followed by 2 to 3 hours of gentle cooking. Add no salt until they are fully soft. Finish with smoked chili, a small amount of lard or good oil, and salt. The flavor is earthy, rich, and unmistakably ancient. Something about the density of the bean, the way it sits in the stomach with quiet authority, makes sense once you understand what it was designed to sustain. Elijah went 40 days on the strength of one meal. The science of what he may have eaten is finally catching up to that record. Number 4. Amaranth. The Spanish conquest of the Aztec civilization targeted their fields of amaranth before they targeted their temples. This was not accidental. The Aztec military, the warriors who had built the most powerful empire in pre-Columbian Mesoamerica, fueled their campaigns with amaranth. They ate the grain daily. They pressed it with honey into protein-dense preparations. They carried on campaign, and they gave it ceremonial status that mirrored its nutritional importance, offering it in ritual preparations to their gods and consuming it communally in what Spanish priests found deeply uncomfortable to witness. The Spanish conquest specifically targeted amaranth fields because the colonizers understood with strategic clarity that destroying the food supply meant destroying the civilization. Cultivation and consumption of amaranth was punishable by death under Spanish colonial law. The result was the near eradication of a crop that had sustained millions of people for thousands of years. 14 grams of complete protein per 100 grams dried grain, all 9 essential amino acids, and the critical detail that makes amaranth nutritionally singular among grains, a high concentration of lysine. Lysine is the limiting amino acid in most grains. The reason corn, wheat, rice, and even quinoa in some analyses are classified as incomplete proteins. Amaranth contains lysine in quantities sufficient to make it a complete protein by itself, and to improve the protein quality of any grain, it is eaten alongside. The Aztec practice of eating amaranth combined with corn was not culturally incidental. It was nutritional complementarity, so precise that a modern dietitian designing an optimal amino acid profile would arrive at nearly the same combination. Amaranth also contains significant quantities of squalene, a compound originally isolated from shark liver oil and studied for its role in supporting immune function and cell membrane integrity. Plant-sourced squalene from amaranth oil has been found in laboratory studies to have antioxidant properties comparable to vitamin E. Researchers describe the findings as preliminary, but consider them worth pursuing in clinical settings. To pop amaranth heat, a dry pan over high heat until a drop of water evaporates in under a second. Add a single tablespoon of dry amaranth seeds. Cover immediately. They will pop within 3 to 5 seconds, tripling in volume. Remove from heat at once. Add the next tablespoon. The result is a light, faintly sweet, nutty grain that can be pressed with raw honey into protein bars. No additives. No synthetic ingredients. Nothing your great-grandmother wouldn't recognize? The Aztec warriors carried these. The recipe has not changed. Number 3. Cowpeas. 24 grams of protein per 100 grams dried. But what makes cowpeas genuinely remarkable is not their protein content in isolation. It is what they produce under conditions that destroy every other high-protein crop. Drought tolerance, extreme heat tolerance, high protein output with minimal water, minimal fertilizer, and almost no external inputs. The International Institute of Tropical Agriculture has documented cowpea cultivation, sustaining food security in some of the most climate-stressed agricultural regions on Earth: the Sahel, the Horn of Africa, regions where annual rainfall can drop below 200 millimeters and where soil nitrogen is chronically depleted. In those conditions, cowpeas do not merely survive, they produce. The biblical record touches this resilience indirectly. In the list of foods, the prophet Ezekiel was instructed to combine in his siege bread that same precise nutritional formula. From the opening of this list, cowpea family legumes appear alongside grains. The combination was not accidental. In siege conditions, extended periods of limited water, limited food variety, intense physical and psychological stress, the cowpea provides protein that remains bioavailable, even when storage conditions are poor and cooking resources are limited. Dried cowpeas hold their protein content for years without refrigeration. They were the food security crop of the ancient world, and they remain the food security crop of the developing world today. What the research has added to this picture is understanding of cowpeas' particular polyphenol profile. The black-eyed pattern on each seed is not decorative. It is a visible marker of a specific concentration of flavonoid compounds that function as antioxidants in human tissue. Research published in the journal Food Chemistry found that cowpea polyphenols demonstrated meaningful antioxidant activity in laboratory studies, with effects that researchers described as worth pursuing in clinical investigation. Cook dried cowpeas by soaking overnight. Then, simmering with a bay leaf and half an onion for 45 minutes to 1 hour. Finish with garlic sautéed in olive oil. The oil becomes a carrier for fat-soluble compounds that would otherwise be lost and add the garlic oil to the beans in the final 5 minutes of cooking, rather than the beginning. This is the preparation technique that traditional West African cooking developed over centuries. The science of bioavailability now explains why. Number 2. Lentils revisited. No. Let's turn to Chaya. Before we reach number 1, I want to pause on something that runs through every plant on this list. Every single one of them was kept alive by someone who cared enough to save seeds, share a cutting, or pass knowledge to the next generation. Industrial agriculture had no use for most of them. They cannot be patented. They propagate freely. They require nothing from a supply chain. They reward the gardener who pays attention and punish the gardener who does not, which is exactly the kind of relationship with food that built human health for thousands of years before the grocery store replaced it. What you're about to hear is perhaps the clearest example of that dynamic on this entire list. Number 1. Chaya. Imagine a leafy shrub that grows like a weed in warm climates, asks almost nothing of you, produces leaves continuously for decades from a single cutting, and was one of the primary food sources for one of the most architecturally and mathematically sophisticated civilizations the ancient world produced. That is Cnidoscolus aconitifolius, known as chaya, called tree spinach, in some Caribbean and Central American traditions, and it is, without question, one of the most underappreciated food plants in the world. The Mayan civilization consumed chaya as a daily staple. It appears in pre-Columbian agricultural records as one of the most widely cultivated plants in the Yucatan. Maya healers, called curanderos, used chaya leaf preparations for conditions they described as weakness of the blood and failing strength in the elderly. Contemporary ethnobotanical research has documented more than 30 distinct traditional uses of chaya across Mesoamerican cultures, from Guatemala to Belize to southern Mexico, with consistent applications for conditions we now recognize as anemia, insulin resistance, and inflammatory joint disease. The convergence extends beyond the Maya. In the Caribbean, particularly in Cuba and Puerto Rico, chaya has been used in traditional healing for generations, with applications that parallel the Mayan uses almost precisely. In some West African communities, where chaya was introduced as part of agricultural development programs, traditional healers rapidly incorporated it into their practices, noting properties that aligned with plants they had used in Africa for centuries. A plant they had never encountered before felt, in their practice, familiar. That kind of cross-cultural recognition is the closest thing ethnobotany has to a controlled experiment. What the laboratory has found is striking. Fresh chaya leaves contain 5 to 7 grams of protein per 100 grams, comparable to cooked egg white. An extraordinary figure for a fresh green leaf. They are exceptionally dense in iron, calcium, and vitamin C, often surpassing spinach, kale, and broccoli across every measured nutrient simultaneously. A study this thing, published in Plant Foods for Human Nutrition, found that cooked chaya leaves compared favorably to conventional vegetables across nearly every measured nutrient category. The iron content is particularly significant for adults over 52, in whom subclinical iron deficiency insufficient to cause clinical anemia, but sufficient to impair cognitive function and physical endurance, is far more common than generally recognized. Chaya also contains significant quantities of HCN-related compounds in its raw leaves compounds that break down completely and harmlessly with 5 minutes of heat. This is not a danger in cooked chaya. It is a reason never to eat it raw. Always cook chaya before eating. Boil or sauté for a minimum of 5 minutes. The cooked leaf has a flavor resembling spinach, slightly earthier, slightly more substantial, with a texture that holds its structure better than spinach does under heat. Here is what industrial agriculture could not tolerate about chaya. It propagates entirely from stem cuttings. No seeds to sell. No seasonal purchase required. Cut a stem. Place it in soil. Water it for 2 weeks. And within months you have a producing shrub. Share that cutting with a neighbor, and within 1 growing season, 2 households are producing food. From what costs nothing but generosity, the plant quite literally cannot be monetized the way the system requires. The Maya did not need a patent system to understand the value of what they had. They needed people willing to share cuttings and teach preparation, the same things that kept this plant alive through centuries of conquest, colonization, and the systematic replacement of indigenous food systems with commodity crops. One important note on the preparation that makes the difference between a good chaya dish and a great one: after boiling chaya leaves for 5 minutes in salted water, drain them and sauté briefly in oil with garlic and a squeeze of lime. The lime accomplishes something specific. Its citric acid enhances the bioavailability of the plant's non-heme iron by converting it into a form the body absorbs more readily. Traditional Mesoamerican cooking combined chaya with tomato and lime. Intuitively, the chemistry behind that combination was documented only recently. The practice is thousands of years old. Here is the principle that connects every plant you just heard about. Processing destroys what ancient preparation preserved. Not selectively, not partially, but systematically. When wheat is stripped of its bran and germ to produce white flour, most of its lysine content goes with the bran. When soybeans are processed into soy protein isolate, the isoflavones that made whole edamame valuable are separated out. When lentils are canned in water with added salt, the polyphenols that made traditionally prepared lentil soup nourishing leach into the liquid that most people pour down the drain. Every compound on this list that researchers are now studying: the L-dopa in fava beans, the squalene in amaranth, the tryptophan in winged beans, the isothiocyanates in moringa, concentrates in the parts of the plant that industrial food processing discards or destroys in the process of making food convenient, shelf-stable, and profitable. This is not a conspiracy. It is physics and economics. But the effect is the same. You can eat a processed version of every plant on this list and receive a fraction of the nutritional value that the ancient cultures who relied on these plants actually experienced. The whole plant, minimally processed, prepared with the techniques that traditional cultures developed across centuries of careful observation. That is what the research is consistently finding when it actually measures outcomes rather than isolated nutrients. And here is the larger question to sit with every civilization on this list: the Inca, the Aztec, the Maya, the Odanum, the ancient Israelites, the Chinese. The Scythians maintained robust physical health across populations without pharmaceutical infrastructure. What they had instead was an intimate relationship with specific plants, specific preparations, and specific combinations that modern nutritional science is only beginning to map. We are not recovering lost knowledge. We are beginning to understand why it was never lost in the communities that kept it alive. If this video gave you something real, share it with someone who is trying to grow more of their own food, someone who needs to hear that the most powerful nutrition available to them may already be growing, waiting, in a garden they haven't planted yet. Subscribe and ring the bell, because next week, we go deeper into the plants that ancient physicians specifically prescribed for the conditions that most affect us after 50. You do not want to miss it. I'll see you in the next one.